Right. In continuation with the torque speed characteristics of separately excited DC motor, part 2. We know that torque is given by this equation, EA IA of omega S, where T, or the tau, is the torque, EA is the back EMF, IA is the armature current, omega S, it is the speed in radians. We know that EA is equals to K omega S flask KE from our previous what? From our previous equation. We are going to substitute this EA, or let's just say E. We are going to substitute this into this. This was our equation 3 from our previous one, from our previous lecture. So we are going to substitute this into this. We are going to be left with tau is equals to what? Is equals to KE omega S flask upon what? Omega S. Something like this, IA. Something like this. Omega S cancels what? Cancels with each other. Then we're going to be left with tau is equals to KE flask IA. This is our equation 4. This is the equation of torque. This is the equation of what? Is the equation of torque. KE, where KE is a constant. KE is our constant. Phi is our flask. IA is our armature what? Is our armature current. But we know that our equation was saying that V is equals to E what? Plus IA RA. That equation, I think this was equation, this was our first equation from the previous lecture. This one, V is equals to E plus IA RA. We are going to rearrange this equation, making E what? The subject of the formula. We are going to be left with what? By making E the subject of the formula, we are going to be left with E is equals to V minus IA RA. This is just the same as this equation. What we have just done, we have made E, which is our back EMF, the subject of the formula. But we know that E is equals to K E omega S flask, something like this. And we know that tau is equals to KE flask IA. We know these equations. We have derived these equations, right? Provided that flask is equals to a constant. Provided that we are just assuming that flask is a constant. If flask is a constant, we are going to reintroduce here KE and this one. So we are going to be like, if flask is a constant, right? If flask is a constant, this one E, which is equals to KE flask omega S. This one, this right here, we are going to introduce a new constant, K dash. Provided that flask is constant. If flask is constant, we are going to introduce a new constant k dash. Therefore, we are going to be left with E, which is equals to k dash omega what? Omega S. K dash omega S. So we are going to substitute this equation into this equation. Upon doing so, we are going to be left with k dash omega S, which is equal to V minus IA RA. Divide by k dash. This one cancels. We are going to be left with omega S is equal to V k dash minus IA RA over k dash. Now we know that torque is equals to k dash again IA, because we were having torque KE flask IA, but provided that flask is a constant, this right here, we are going to introduce a new constant k dash, which is this one, k dash. Torque is equal to k dash times IA being the armature current. We are going to make IA the subject of the formula. We are going to be left with IA is equal to tau over what? K dash. We are going to substitute IA into what? Into this equation. Upon substituting IA into this equation, we are going to be left with what? We are going to be left with omega S is equal to V over K dash minus IA. We are saying that tau over K dash is equal to what? Is equal to IA. We are going to substitute tau RA upon bracket K dash bracket K dash. Now we have got two K dashes, which is going to be omega S is equal to V over K dash minus tau RA over K dash squared. K dash squared. So this is our equation. This is the equation of what? Torque speed characteristic. You can see that we've got speed here, we've got torque. Thus, the torque speed characteristics can be derived from this equation. Let me just erase this stuff here. Let me just erase this stuff here so that the equation can be seen what? Can be seen clearly. Omega S is equal to V upon K dash minus 2 or tau RA upon K dash squared. If we are to draw a graph of this equation, our graph is going to appear something like this. Torque omega S just appears somewhat constant. The graph separately excited DC motor. This is the speed time characteristics. Although we are saying the torque speed characteristics of separately excited DC, whereby our y-axis we are having the what? The y and the axis we are having our torque. And this obviously when our torque is equals to 0, we will be having this what? This speed. So this is the torque speed characteristics of what? A separately excited DC motor. Torque speed of separately excited being derived from this equation, being derived from this equation. I thank you.